All right, so thanks for showing up. It's kind of loud. This is from bottleneck to billions, how our database migrations unlock massive scale. Real quick, just anyone's first fintech DevCon? All right, mine too. So pretty much everyone engineers, I don't know, product people? Yeah, all right, right on. Thanks for coming. So I'm an SRE on the infra team at Moov, and you might guess, we kind of just do all the underpinnings, CI/CD, DevOps, all the things that it takes to make Moov do what it does, mainly on Kubernetes, got databases, Kafka for messaging. But that's not what we're here to talk about. We're here to talk about how, or maybe more importantly, why we decided to move all these databases off of MySQL to Postgres and from Cloud SQL to AlloyDB. Well, here's a good reason. I found this in Slack. JJ, you are here. I hope you don't mind me quoting you. Architects tend to be frank. Ours is no exception. They also tend to be correct. And that's also the same with JJ. His feelings weren't singular. They're shared across the organization, and we'll get into that a little bit more. But it wasn't just problems we were seeing with performance or costs. We were impacting feature delivery a little bit. So we're going to get into that a little bit more. First thing we saw was I/O wait. We have these tests called Gatling tests. They're basically load tests. We run them in staging. The goal is to run transactions and API calls and things like that a little higher than we see in prod, right? The goal is to catch things before your user does. That's always, you failed when your user is telling you have a problem. So we were seeing problems in Gatling. We were seeing I/O wait, which caused CPU spikes and other things. And we had a couple things we could do. We could grow our instances, pay more money. We could allocate more disk for IOPS, paying more money. But when really that's all you have to throw at a problem, you've got to do something at some point soon. Like I mentioned, we were also blocking a few features. Product was looking for a way to improve search in our dashboard. If you typed in an account ID or a merchant name just right, it'd pop right back up. You click it and you move on. But if you missed a number, the A was a 1 or an L was a 1 or whatever, the search algorithm would go off and you'd be waiting 20, 30 seconds in a web form, or, in a web search box in a window. And that wasn't okay. So they're like, cool, we'll use fuzzy search. And we're like, well, we can't really do that well in MySQL. We started talking about Elasticsearch and OpenSearch, and I don't know if you guys have ever run one of those, but those aren't fun to maintain or pay for. But really what we were doing was we were dancing around this problem, right? If we could get to a database where we could do these functions natively, we wouldn't have the problem. So at some point, we realized the writing's on the wall. We've got to leave MySQL. So we finally kind of faced that decision. The question is, where do you go? So, I put this graph up here just to kind of give everyone a feel for what's out there. We're in GCP, so this is kind of our domain. We needed a relational database, so that puts us sort of more on the yellow side. We were on Cloud SQL having problems, so we looked at Spanner and Alloy. Spanner is pretty impressive, massively resilient. I think 5 nines in the SLA, but pretty complex, and you have to size it right. It's, I think, 2017, 2018, but client library support, depending where you are, can be an issue. Anyway, when we looked at it, and we did move some workloads to Spanner, but a lot of them ended up going to AlloyDB because we thought we had a better migration story. Alloy had what we were looking for, really fast, low latency. We'll get into a little more details here, but really good performance. It uses Google GCP's Colossus storage engine on the back end. If you know anything about like Borg and what that did for compute, this is their answer for abstracting storage. Specifically to Alloy, they have the columnar engine, which is basically just doing like indexing on the columns. We've got embedded vector support for AI applications moving forward. So that's basically like you store your data, cool, but it's also going to be storing alongside it vector data to represent your data right alongside with it, and you can do some really interesting things. And so we have that capability built in moving to the future. 4.9's SLA. The resizing or upgrades or failover scenarios are really compelling. They spin up an instance right alongside. They're handling, transactions, keeping everything in sync, and then the switchover is basically like, swapping the back end and the load balancer or something, and your connections drop, but then you're immediately able to reconnect, and you've got everything you need. It also had really good plugin support. Everything we wanted from Postgres was available there. So Alloy's like Postgres under the covers, but they bolted on a lot of things to make it more performant and to add some use cases. So great, we're moving to Alloy, but how are we going to do it? So I've done some, hands up who's done database migrations in the past? Yeah, they suck. No one wants to do them. So the way that I've done them in the past is, you turn off the application, take a MySQL dump, do whatever you need to do to make it ingestible in Postgres, and then, like run yourself a PG restore and kind of hope everything went to plan. So, that wasn't going to cut it for us, not for our workloads, not for the critical data we have in our databases. So we started identifying a tool chain that would work for us. Stream was one of the products we found kind of near the beginning of our search. I had never heard of this company before, but they had some pretty impressive claims. ETL capabilities, fine. TQL configuration definitions that'll basically let you define your data pipeline and your translations in the flow. Change data capture for more load-friendly transfers and real-time data synchronization. QR codes just to their main website. They also support reading and writing a bunch of different databases. SQL Server, MySQL, Postgres, Oracle, DB2. Like anyone running DB2? Sorry. Anyway, you can migrate your databases this way. So being a fintech and having the sorts of type of data that we have in our tables, we found it extremely important to us to validate what we were syncing. The idea of just saying, okay, Stream, like let's get the data moved over, and you tell me it's done, and you tell me you copied everything, that's not really going to cut it. We wanted a third-party app to really tell us, yes, everything that's in the source is in the destination. We've looked at everything, we've compensated for all the data type disparities, and we've got everything. So Google, I think it's actually the guys in GCP, maybe the professional services, released this, open source this tool. This is a QR code to their GitHub repo. But many, many different validation options. They can, again, speak to many different databases. You can match on some or all of the columns in a row. You can do a hash to compare. You can concat and do a string compare. There's a lot of options. It's a pretty complex tool, but also really, really powerful. Also has the ability to partition up tables. So, if you got 100 million rows in a table, you're not just going to single thread that, right? Break it up, spread it out. So this was a really huge step for us as well as far as our tool set was concerned. The next thing was approach, right? So, and one of the big reasons I put this slide in here was I didn't know exactly who I'd be speaking to, right? So I'm on sort of more the infra team. We have dev teams that, ops and own the services that rely on these databases. We're not operating in a vacuum. We all have to work together. And so think about your role if you're planning such a project. Where are you sitting, right? Are you dependent on an infra team? Are you the infra team? What is the blast radius of hitting a certain database, right? Think about all these things. At the end of the day, you're dealing with humans, and you got to have everyone on board with what you're doing and how you're going to do it. So let's just go through this real quick. Always staging first. That just sort of goes without saying. Then move on to your less critical services. Maybe an example of this is a new service that's still running in the old database for whatever reason. not too many users. Maybe it's not even GA'd yet, right? So it's like a real service. It represents a modern incarnation of what you're doing as far as services, but it's not critical, at least not yet. Maybe there's batchy services that have to be up during certain windows or can only be down during certain windows, right? That affords you an opportunity to dry run, try some stuff. Doesn't work, fine, back it off. There's no state changes during those times. So that's another one. Another one I'll call leaf services, or services that are production, they're GA, they're out there, but their blast radius isn't so large. If you mess them up, you're not going to screw up too many, you're going to have too many cascade effects, and you can manage them. And then lastly are your sort of core services, right? You take one of these guys down, and a lot of your solution is impacted, right? You're going to have a lot of users complaining, and you're not going to like what happens if one of those goes wrong. But don't worry, at this stage of your journey, you're probably getting to say, I'll deal with that later. So that's sort of like more organizational. More on your dev side, you need to be thinking about service reconfiguration, right? What are you moving from? What are you moving to? Your service needs to be able to sort of play with both databases, maybe not at the same time, but they need to be able to stop using one and then being turned up on the other. MySQL to Postgres isn't too bad. There's some rules, but we had a pretty good templating strategy for a lot of our services where we were able to capture a lot of the translation between the two. So you got to think about your client library support. What about dev testing, right? So some people don't have like full production environments when they have in the dev test loop, right? Maybe you're running that stuff on your laptop in containers, whatever. You need to also update, your local testing databases, and that's where you can get your service really switched over and configured for that. And then another good idea, define the destination schema ahead of time and maintain it, right? So this is going to be a months-long project. If you add a table or you can do a schema change in a table, you got to do it twice, right? Because you have to keep that compatibility all the way through. And then when you get really close to migration, it's even more important, right? Don't want to be doing a schema change like a week before you're going to do the prod cutover. So this is good examples of things you need to think about on the service reconfiguration side. So migration prep, right? The goal is as little downtime as possible. So as many things you can lump into that bucket of while the service is still running, you want to do that. So the easy things, right? We can create the new database in Postgres. We can create its tables in accordance with the schema that the dev team already specified and agreed upon. And then we create these things in Stream called apps. They call them apps. And really, they're just sync jobs is the way to think about it. And we create 2 per database. One is the initial load, and that's probably exactly what you think it is. We're just copying everything from the source to the destination. Don't care what it is. We keep track of when we define that app, and we assign that as the start time to the second job, which is called the CDC, which we talked about earlier, the change data capture. And the way that works is the CDC job is not reading from the database, it's reading the write-ahead logs, right? So every time a transaction is done, we write ahead what we're about to do, and then it's done, and then we commit it, and everything's cool. So the CDC job sits there and is watching the wall logs from the start time that you specify, and then it just keeps running, right? Every time something happens, it catches it off the wire in the wall logs, and then makes the corresponding change in your destination database. So we can do all this without impacting the service at all. We can also run our initial data validation, and what that allows us to do is learn a lot of lessons, which we'll talk about really soon. But MySQL and Postgres don't agree on a bunch of things, and Stream makes some choices for you, and you need to kind of catch that and make sure you're ready. That's a bit of a loop, those first 5, but once you've got your jobs kind of set up and you got your initial data validation going, you're pretty much ready to engage with that dev team and set a date to cut the thing over. The nice thing is that the migration process itself is actually not that much different than the prep, right? It's kind of just the dry run for actually cutting it over. So the process we arrived at was, the very first step's the most important one. There's a number of reasons why stream jobs might stop. It's just a VM running some Java code. A couple of times we found that those jobs had stopped, and you don't want to turn off your service and commit to a cutover if you're not synced. So make sure the CDC is running, stop the service, and then this is sort of our critical section, right? This is where we're having user impact. Run the final data validation, do it as fast as possible. You got to configure the service to talk to Postgres on the way back up, and there's one other thing we'll talk about in a little bit, and then start the service, and then make sure that it's up and running and happy. But that was pretty much the process. I'll go ahead and apologize in advance. This slide it just takes a while, but there's actually some good stuff in here. This is a great opportunity to shout out a teammate, Jeff Browker on my team. He did a lot of work in validation. There's so many when you're talking about billions and billions of rows in hundreds of tables in over 100 databases, you're just going to find every single little thing. And so you may not be going MySQL to Postgres, but these are the types of things that crop up that we found during our journey. Times and dates are always hard, right? I mean, anyone who's a software developer knows that. There's like umpteen calendars and time zones and daylight savings time and how many seconds, how many digits of precision in seconds. So the idiosyncrasies here are that MySQL allows 0 date timestamps. So 0th year, 0th month, 0th day, hours, minutes, seconds, on down. And Postgres doesn't. It just doesn't support that. Stream can be configured to write different things, which is where your homework with Stream would kind of continue. I think we took the default, which is like December 1st of year 1 BC at midnight or something. But these are kind of the details you got to get into. Another thing is that nulls are not okay in strings in Postgres. It's written in C. A null means that's the end of the string. So you can't have a null like inside your string in Postgres. That's just not okay. MySQL, it's fine. MySQL doesn't have a Boolean. They do a tiny int, 0 or 1. Postgres has a bool. Be silly not to use it, so we did. And then other data type disparities. Another example is like MySQL has a set. Think of it like a multi-select, like in a drop-down in a web form, right? This one, this one, this one. Stores those values in the schema of MySQL, and then the actual value in the row is just a binary stored bit mask, right? You just copy that over in Postgres, like what? So that's normally handled by just making it a string, CSV values. But that's actually a good moment to call out. This is where you should be working with your dev teams. It's an opportunity to strengthen validation in-app where you may not get it back relying on the database layer, right? These are all things that we on the infra team hit, and then it's like, oh, okay, guys, what do you want to do about this? Let's see, auto increment, right? So in MySQL, you can have usually primary keys, right? Valid values that, increment every time you insert, you get one higher, that sort of thing. Postgres has that, they call them sequences, but it doesn't make sense for Stream to do that, right? In the initial load, maybe, but if you have a CDC running, it doesn't make sense to say, okay, cool, I caught this thing, that results in a new row on your destination side. Oh, and I should go find this sequence thing and change it, right? It could be happening all the time. And so that's a thing that you just need to think about. Another thing, these are sort of more higher level, but consider boosting your source and destination database resources. That initial load is really gonna hit it. And then data validation, there's no way around it. If you're checking all the data, you're gonna be doing tons of reading on both sides, and you don't wanna impact your production workloads. So consider that before you really get going. And then the last thing, the QR codes for this is what I call the quotas in Stream. It's sort of like guardrails that you see in public cloud. They're set pretty conservatively because they don't want to impact you. but like we were limited, we found in a pretty profound way on like the number of jobs we could actually have, the number of apps, that you could have configured and running at any one time. Load on the server was really low. Java didn't even think there was a problem in its virtual machine, but it was just sort of like, you can't do this. But there's actually a website here on Stream's website where you can reconfigure a lot of this stuff. Obviously be careful, really important stuff, prove it out, but we found it to be pretty conservative. So for a while we were doing migrations and we were learning lessons, and we basically had like one infra team member kind of take the lead on each database as it came through, and that was fine. But we finally hit that stage that I was talking about earlier in the approach slide, where we got to run. So it was our big 12 services is what we called it. It was the most critical dozen services. They couldn't be down. They'd impact everyone. So we had to do them at the same time with as little downtime as possible, with in the middle of the night without any mistakes. And we were feeling like Dave over here, kind of like, please, we just want to keep doing the easy ones. So we knew what we had been doing wouldn't scale, wouldn't do it for the critical big 12 here. And we were tasked with moving these 12 in production in less than half of a 2-hour maintenance window with as little impact to customers as possible. And so we took stock of where we were, and we said, our validation has to be a lot faster than this. We were just running it on laptops, as we needed. But these databases were not only critical, they were also huge. They represented about a third of all the rows that we had to migrate, and we had to do it like all at once. So we needed to be able to do our validation a lot faster and in a much more reproducible way with provable results. And like I told you earlier, we had made sort of an organizational decision to validate every single bit of data as we migrated it, right? No skipping anything. And so we also invested time in simplifying our processes. So at that point, it was kind of like, a couple pages in a Notion doc, like get this stuff done and you can migrate the database. We invested some time and some scripting, and we made the process a lot simpler, less error prone, able to be accomplished at midnight with a bunch of coffee going through your veins. We also needed, like I mentioned, support for big tables, so that's where the partitioning on the data validation tool comes in. So opportunity to shout out another member of my team, Adam Jackman. He proposed pretty early on and implemented the idea of running all this validation massively parallel in Google Cloud Run, right? So kind of taking on the whole serverless thing. Cloud Run jobs defined in GCS buckets, run in Cloud Run, and then results stored in BigQuery. And this is kind of cool. Because obviously we could take every table, make a job. If the table was large, we could split out the job into a bunch of tasks, and we could get way more throughput on our validation. Again, boost your DB resources before you start slamming it with this kind of stuff. Yeah, so we were able to do it off laptop, results checked by anyone in the company, boom, a lot faster. So this is our simplified process, right? Basically, first set up the destination database and the tables and the schema on a per service, per database instance, and set up those stream apps. Boom. After you got the stream apps running, so the initial load will happen automatically, and then you start your CDC after the initial's done. And then you can run your validations, or run your setup for your cloud validation. So that's creating the cloud run jobs and kicking off, the run prep is kicking off the validation. Wait for that to happen, and then we had a bunch of scripts where we could kind of like check row counts, how many do we have on each side, tasks, what were the results of the Google Cloud Run validation tasks, and see what happened there. If any failed, as evidenced by validation tasks, you could run the failed and actually get the rows that failed to validate, right, back. And we'll be able to see that here in a little bit. And if that didn't work, we had a one-liner for just nuking everything from orbit and starting again. I can tell you that last one was really terrifying. Like, that ledger service in prod, you know it's running in MySQL, you know the migration hasn't happened, but you still check that manifest and you're like, okay, yeah, this is okay. Drop tables, are you sure? Yeah, okay. Pretty nuts. So quickly, like I mentioned earlier about big tables, Google Cloud Run's max is a 8-core, 32 gig big machine, and that may seem like a lot, but if you're doing millions and millions of rows, and they're even slightly off, especially if they're slightly off, there's a ton of compute involved with like, am I sure this doesn't match some other row in this database? And so it takes a lot of horsepower, but that's what makes Cloud Run really good at this. Using that partition option in the data validation tool allows you to break, if you have a 10 million row table, break that up into 10 parts. You can do that much, much faster. Fun fact, when you say give me 10 partitions, it'll actually give you 11. It'll break up that 10 million rows into 10 1 million row chunks, but it'll give you an 11th, which is basically from now until whenever you run that validation next, right? There's CDCs always adding new stuff, so that 11th one always gets kicked in there. Right, so let's take a look. We've already completed a lot of our, we've completed all of our migrations at this point, and actually we're about to merge a bunch of code that actually removed the ability to configure MySQL databases for our services, and last week when I got this talk finalized, it's kind of like, let's hold off on merging that. I'm going to show whatever I can here at the demo. So, oh my goodness, you can't see any of that. Let's Can you guys see that okay? Ish? Okay, good. All right, so one of our services here is called Disputes. I picked it because it's not so big and it's kind of easy to just talk about. Had some good examples for me. So I'm just going to go ahead and run that run prep command. And what this bash script is doing is it's taking in the local configuration from our repo. We had a repo just for our migration efforts. And it's going through the GCS bucket. It's checking, do I need to update this config? Do I need to update this config? Finalizes all that, and then it updates Cloud Run jobs if necessary, and then it kicks off the Cloud Run jobs all in one shot. Boom, everything is running. Cool, I'm in my critical section. I've shut down my services. I'm running my validation to make sure everything's okay. If we were actually migrating a service here, we would have a Terraform running, right? We'd have a plan that's like, hey, I'm about to rip out all your MySQL and put in your Postgres. Are you sure you want to do this? So we need to have that at the ready to minimize our downtime. Really quick, if you want to, we can look at the GCP console and what that looks like in here. You can see status of last execution is kind of spinning. And each of these jobs, you can go into them and see when they were run, how long it took to run them. So that's kind of like here. And then for each job, you can look at the tasks. So if you had set up partitions, you'd have n+1 of those on the right with them all working in parallel. And really, they should all succeed all the time. It's not like this validation worked or not. This is just my job completed or not. The only time we ever saw these fail was basically if you ran out of memory, and that's how you knew how to add some partitions to your task. But anywho, back here, so our service is down. We got our Terraform plan ready to apply. We've kicked off our validations. There's two things we're going to do in this critical section. One is to update our sequences. Remember I was telling you, if you don't update your sequences on the destination side, then when your app comes up, it's just going to start writing again, starting at 0 in that auto increment column, and then you're going to have dupes, and then your app's going to hate it, and that's going to suck. So the other thing you're going to do is, so you're going to update your sequences, and then you're going to check that plan and make sure, yes, for sure we're ripping out MySQL, for sure we're adding Postgres. And then before you can turn it back on, again, organizational choice. If you trust your dry runs, if you trust Stream, and you trust your validation with maybe some stuff in flight, you don't have to take this step. But like I said, it was sort of a company decision. We were going to validate every single thing. So there's really no way to do that apart from turn service off, check it all, turn service on. So that's this stage that we're in right here. So after your validation is complete, and you can kind of keep an eye on that, either using the script or you can use, you can check that Google GCP console. You can see in here, and then if we were in the middle of a migration, our hearts would kind of stop and say, oh crap. But like I mentioned, we've already completed our migrations here, and obviously I've checked all this stuff well before I presented it in front of y'all. But in the vast majority of cases, all of these failed because there's data in Postgres that's not in MySQL, right? We've already migrated off of MySQL, and so there's a bunch of stuff that's in Postgres that's not in MySQL, and so we're failing these validations. Oops, sorry. So we'll run our validation failed script. This is pretty good. It'll give you a summary at the top, and then it'll go through each table, and it'll show you each row that failed and give you kind of a summary as to why. You can see for the vast majority of these, MySQL exists is false, and Postgres exists is true, and that's the reason it failed. No big deal. We've already migrated this service. But I did find a table that had some interesting results in it here. A lot of these are MySQL exists true and Postgres exists true. And when that fails, that means something inside the row is different, and that could be a problem. So we're going to go and take a look why. Sometimes this stuff becomes a little bit of a gopher hunt, but in this case, I've done all the homework for us. If we take a look at the updated on column, we can see that the 0 date thing bit us here. So on the left is MySQL, and it's got a bunch of just 0 timestamps. And on the right, yeah, December 30th, year 1 BC at 00000. So take a quick look here. So yeah, so we've got 24 rows that are 0 dates on each side, and we got 24 year 1 BC dates on the Postgres side. So we can feel pretty comfortable. It doesn't guarantee anything. In our case, we went and did a lot further validation, but this is enough right here to show me what's going on. But remember, we had how many? We had 26 rows here that failed. So where are the other 2? And the answer is we've got two rows that were added after the migration that never existed in MySQL. But this is the type of tooling you can develop to give yourself a lot more comfort as you go through in a really, really low downtime scenario. Why is this failing to validate? What's going on here? If everything goes really, really well, you run that first command up here, and you just kind of see a bunch of green, and you're like, great, everything is exactly, we took all the fields, we hashed them, and we compared them, and everything's green, everything matched up exactly. That's really what you want to see. And if you have validation issues, you want to figure that out like staging or before, if at all possible. So that's just a glimpse into some of the tooling that we developed just for this effort. As you kind of saw, like the way we structured this repo, it's all by instance, by app, and then the environment that it's in. It allows you to be very quick. It allows you to run all the same commands, and the only contextual change is just where you are in that repo. Where you are like specifies the types of validation you're going to do, the schemas that you're working with, and then if necessary, like templated configuration information, like even templating in secrets to access databases, right? They can be different for each service, whatever like that. So highly recommend a dedicated repo for your efforts. Let's see here. So that brings us through the demo part. There we go. So let me make sure I just covered everything I thought I was going to say. Yeah, that's about right. So after you get your validation, boom, your service turns on, you're checking it all, right? think of all the stuff you need to do, postman checks, various API calls, you have an ops dashboard or something like that that helps you validate proper function. You don't want to just get all the data from here to there and say, cool, on the infra team, I could just say that, right? Cool, I got the data there, I promise, it's all there 100%. But if the app comes up and starts acting weird, problems, right? So you're gonna be checking that stuff hardcore in dev test, your whole loop, then staging, give it a little time to bake, then prod, check it all the way through. Our CEO, Wade, posted this in Slack the day after the prod Big 12 migration, and it was really, really cool to see. It was a lot of work to get to that point. In fact, fun story, we had, during the staging version of Big 12, at the very, very beginning, we were working through a service and the wrong PR got merged, the prod one got merged instead of the staging one. And the rest of that staging exercise was like getting that prod service back to MySQL, like, oh goodness, what happened here? And that took some time. The second time we tried the Big 12 staging migration, Google went down. I don't know if you all remember that. That was June, I think. We all hopped on the Google Meet call, or some of us did. Some people were in Slack saying, I can't join the Google Meet, what's going on? And the rest of us in the Google Meet were saying, why can't I get to like the GCP console? And so we were real quick, like, no one merged anything, promise. But it was like a huge blow to our confidence. And then the third time was the charm and everything worked out. Thankfully, the prod migration worked just fine. No glitches at all. But, even all those Big 12 services weren't down for that entire duration, right? We were able to bring them back up as soon as we had validation. The smaller ones validated quicker, and we were able to achieve that lower downtime for each service. So just to give you an idea of our timeline, JJ back here merged some changes to our open source base repo in the Moov.io org in September of 24 to add Postgres support. By December, we had kind of gotten through our tooling due diligence. By February, we had migrated the first database. That was kind of late. It was like February 24th or something like that. By June, we were able to accomplish the Big 12 in production. And then I'm happy to report, after we had the process and we were in the groove, we were able to complete the last database here just a few weeks ago, really. It was late July. So that was kind of the whole thing from start to finish. Once we had decided to boot MySQL, you just get it done. And so maybe it took a little longer than we were hoping, but we couldn't get this wrong, right? Services had to be up, schemas had to match, rows had to validate whole way through. So zooming out a little bit, some other lessons that we learned. Expect to find tech debt, right? So, database migrations don't happen very often. And you're going to find stuff, right? Like take the 0 date thing. Imagine a service that just says like, okay, if it's 0, then assume something, right? You get the Postgres, it's not going to be 0. It's going to be what? Year 1 BC or whatever it is. And so it pays to kind of work with your dev teams, make sure when you see something weird or see something that's going to change, work with them, reach out, be proactive, and say, when this changes, is this okay? Or if we change this data type, how's that going to impact your application? And try and embrace it. Like no one wants to work on tech debt. But when you're changing something as fundamental as its database, it's important to get it right. It's important to try and get cycle. Like, the product owner won't be thrilled. They want feature. But getting this right is important. As I've talked about throughout the talk here, it's a team effort. Infra can't do it by themselves. Dev teams can't do it by themselves. You got to work together. It's worth it. The latency drops we've seen are pretty amazing. The CPUs are down, core for core. It's just more performant on Alloy than it is in Cloud SQL. And Postgres in general is just more important. We found it to be, for our use case, more performant than Postgres, better than MySQL. And then very last thing I'll say is record a migration, because someone might ask you to give a talk about it, but we didn't do that. So Thanks very much. That's pretty much the presentation. I'd love to take any questions from you. And I guess before that, like just grab, I love talking about this stuff, so just grab me at any point. Happy to talk your ear off about all the stuff we've been through. And it's fresh in my memory too, so happy to go through it. But appreciate you, everyone. Yeah. Yeah, I was talking with JJ about that actually. We had some Windows slip in terms of data retention from some of the old MySQL metrics. We have a lot of stuff on Postgres now, and again, just didn't save it. Like saw the data, cool. I really wanted to get some graphs to show in here because I know everyone likes squiggly lines, but we couldn't show it. So. Yeah, so JJ was talking about Colossus on the back end of Alloy. It's got some really impressive capabilities. On the right side, you're writing into a redundant, resilient, but ostensibly a cache on their side. It's replicated, and as soon as that happens, you're returned back on your query, and they'll figure out where to life cycle it down into SSD or spinny disk or wherever it's going. But super fast on the right side, and then on the read side, a lot of caching. A lot of retention there, and it's adaptive to the types of queries that you're doing, so it'll keep track of what you're doing and keep a lot of stuff in the hot areas real warm for you. So yeah, real big improvements on that. With Cloud SQL, they're basically running a GCE instance for you, and the SSDs on the back end are just their typical GCE, not GFS or anything, just dedicated SSD or whatever like that. They're susceptible to the same issues you get with burst tokens and things like that. You blast it for a while and it'll keep up and then it'll just fall right off. And as JJ said, you don't have a whole lot of visibility into it. So.
MySQL itself isn't bad, but it's more designed around like websites and faster reads over faster writes. Because it's indexing right at primary key into the page files.
Yeah, and don't. Right. Yeah. So Jay's talking about how MySQL's more, better at read-only type of stuff. I don't know about y'all's workflows, but for us, it's almost a read, always a read, and then a write, and so it's very balanced. It's very constant in that way. So, any other questions? Yeah. So the question was there anything specific to Postgres that we noticed inherently when moving from MySQL? Yeah. Sort of out of my wheelhouse a little bit being on the infra team. I know JJ worked on it a lot with the other architects and with applications folks, so I don't know that I can speak directly to that. Anyone? Yeah.
For the most part, the biggest bonus was we were seeing a lot of locking in MySQL due to us just adding an index. You always add indexes when you find a new use that's being added or whatever. Well, it was kind of a pain in the butt because sometimes it would just lock the transfers table and we were not able to process transfers for minutes to an hour. We had an incident over that one, so we were like, okay, this
Yeah.
part of Postgres. So like, you know, all the niceties of Postgres just with a better data store.
Yeah, it's a good point, and like that sort of, it's not something we heavily leverage, but that was kind of the big seller for Postgres when it was developed, right? That it wasn't just, you know, relational, just SQL. That, you know, people wanted performant analytical queries. They wanted non-standard data types. So the GIS capabilities, the other stuff like that, was really the premise of Postgres, and it's really done well over a long period of time. So. Anyone else? Yeah.
You touched on VectorDB briefly at the beginning. Are you guys using that?
We haven't really used it very much. I think there's one table in one database that's PG Vector at this point. So not massively used, but I think it's going to be something we're going to see a lot more coming up. A lot more AI application to all the data stores. So.
Also switching to the columnar indexing.
Sure.
Tablet gives you so that we can create pretty graphs on the dashboard faster for the customers. Without having to, you know, get something like time scale TV or something like that. Who actually generates like your progress and revenue and all that stuff.
Right.
Pretty slow on SQL and stuff like that. But at least with a columnar index, that'll be like instantaneous.
Right. So, good. All right. I think it's already lunchtime, so we'll call it a wrap. But yeah, feel free to talk to me anymore. Thank you.